Hello everyone, this is Babitha working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering. In this session, I am going to discuss the questions related to the multi-stage amplifiers as well as the power amplifiers. So in the case of multi-stage amplifiers as well as in the power amplifiers, we are going to see the classification of different multi-stage amplifiers and distortion in the amplifier circuits. And in order to make the multi-stage amplifier, what are the different coupling schemes we are going to utilize here, and the frequency response and analysis of different multi-stage amplifiers, that is the RC coupled amplifier, transformer coupled amplifier and the direct coupled amplifier. In that all the amplifiers, we are going to see the frequency response of these circuits. And next, we are going to see the Cascade amplifier as well as the Darlington pair. And next, we are going to see the transistor at high frequency model, and we are going to calculate the cutoff frequencies as well as gain bandwidth products of the multi-stage amplifiers. And along with that, we are going to discuss different power amplifiers, that is Class A, Class B, Class AB and Class C amplifiers, and about differential amplifier. So the questions related to these particular concepts we are going to discuss now. So in this questions, we are having three types of questions. The part A belongs to the problem solving and critical thinking questions. Okay. And the part B belongs to the long answer questions. And the part C belongs to the short answer questions. So I am moving to the part A, that is the problem solving and critical thinking questions. So in this, we are having total 10 questions in the problem solving and critical thinking questions. So the first problem given in the part A is a CE amplifier uses the source resistance as 1 kilo ohm and the collector resistance is 15 kilo ohms and the emitter resistance of the first stage is 100 ohms and the collector resistance of the second stage is 4 kilo ohms and the emitter resistance of the second stage is 330 ohms and the R1 200 kilo ohms, R2 is 10 kilo ohms of the first stage. And similarly for the second stage, R1 is 47 kilo ohms and R2 is 4.7 kilo ohms. Okay, so the given H parameters, input impedance, reverse voltage gain, forward current gain and output impedance are common for both the stages. Compute the individual current gain, voltage gain, input resistance, output resistance and as well as overall parameters. So in order to solve this problem, we have to analyze the second stage first, later on first stage. Then we have to find the overall parameters. We have to multiply all the parameters of first stage as well as the second stage here. So in order to calculate the parameters, we require the formulas. So these are the formulas related to the required parameters. So this can be applicable for the first stage as well as the second stage. Why? Because it is the two stages are common emitter configuration only. And to solve that problem, we require the H parameter values for the three configurations. That is also I am mentioning here. So by utilizing that formulas and this table, we can able to find the given parameters. So this particular problem we have already discussed in the case of problems on multi-stage amplifiers session. And next, build the circuit diagram of direct coupled Class A power amplifier and explain its operation. Show that the maximum conversion efficiency is 25%. So Class A amplifier, generally Class A amplifier will operate for the total through 360 degrees here. So that is the direct coupled amplifier we are taking. We are not utilizing any coupling elements between the one stage to next stage. So we have to take the direct coupled amplifier and then we have to explain the construction of that one as well as operation of that one. And next, we have to find the efficiency of that one. So in order to find the efficiency, we require the DC power as well as AC output power from the amplifier here. So in order to find the two powers, we require the voltage as well as current. So from the above circuit, we can calculate the two values. If you substitute the two values in this power equation, we will get the AC power as well as the DC power. If you substitute the two values, we can able to get the efficiency. So theoretically, we may reach 25% of efficiency only in the case of Class A power amplifier. So next question is, for a Class B power amplifier driven from a 24 volts power supply and driving a load of 8 volts. So Class B power amplifier, the supply voltage is given as 24 volts and the load resistance is given as 8 ohms. So we need to calculate the DC power as well as AC power and the efficiency. And the peak output voltage across the load resistance RL is, peak output voltage V0 is equal to 22 volts maximum here. So this problem is similar to the previous problem what we discussed in the above problem. The same formulas we have to utilize to find the AC power, DC power as well as efficiency of the given power amplifier. So this problem we discussed in the problems on power amplifiers session. Next one is, a CE amplifier uses the source resistance as 1 kilo ohm. The collector resistance of the first stage is 15 kilo ohms and the emitter resistance of the first stage is 100 ohms and the collector resistance of the second stage is 4 kilo ohms and the emitter resistance of the second stage is 330 ohms and the R1 value is 200 kilo ohms and the R2 value is 10 kilo ohms for the first stage. For the second stage, R1 value is 47 kilo ohms, R2 value is 4.7 kilo ohms. And the H parameters are given: input impedance, reverse voltage gain, forward current gain, and the output admittance. For this problem also, we need to find the voltage gain, current gain, input impedance, as well as output impedance. So in order to solve this problem, we have to analyze the second stage first and then go with the first stage. So to analyze that, we have to utilize the formulas of the current gain, voltage gain, input output impedance of the common emitter configuration and along with the given H parameters. So these H parameters and given resistance values in the required formulas, we can able to find all the desired values. So this particular problem we already discussed in the problems on multi-stage amplifier session. And next one is, for a Class B power amplifier driven from a 24 volts power supply and driving a load of 8 ohms. So power given it as 24 volts supply, that is VCC is 24 volts, and here we need to find the PDC power and the AC output power as well as efficiency if the voltage across the load resistance is 22 volts maximum. So in this case, from the current and voltage, we need to find the DC power as well as AC power, then efficiency of the given power amplifier. So this particular problem we discussed in the problems on power amplifier session. And next one is, a CE-RC coupled amplifier uses transistor with the following H parameters. So the H parameters are given here. So the value of GM at the operating point is 50 millimos. So GM value is given it as 50 millimos. And the biasing resistance between VCC and the base is 100 kilo ohms. So R1 value is given it as 100 kilo ohms. And the R2 resistance is given it as 10 kilo ohms. 10 kilo ohms. The load resistance value RC is given it as 5 kilo ohms. And the capacitor value is given it as 160 picofarads. And the coupling capacitor is given it as 6 microfarads. Calculate one stage of the amplifier, that is mid-band current gain and mid-band voltage gain here. So voltage and current gain at mid-band range we need to calculate from the given parameters. So this problem we already discussed in the case of multi-stage problems on multi-stage amplifier session. And next, a single transistor is acting as ideal Class B amplifier with load of 1 kilo ohm. If the DC collector current is 15 amps, determine its efficiency. So the given amplifier is the class B amplifier. The load resistance value is 1 kilo ohm and the collector current IC is given it as 15 amps and the supply voltage is given it as 20 volts. So from this we need to find the efficiency. So to find the efficiency we require PDC and PAC. So to calculate this PDC and PAC, from this values we can calculate PAC as well as the PDC values. So once we know the PDC and PAC values, we can calculate PAC by PDC into 100%. That will give the efficiency of the given class B power amplifier. So this problem we already discussed in the problems on power amplifier session. And next, draw the circuit diagram of class B push-pull power amplifier and derive an expression for its conversion efficiency. So here we have to take the class B push-pull power amplifier. So for that purpose, first of all, we have to explain what is meant by class B power amplifier and how much amount of angle it is going to utilize. Okay, and these are the input and output waveforms of the class B power amplifier. And next, class B push-pull amplifier and its construction and how it is operating alternately by providing the alternate voltage positive half cycle as well as negative half cycle. And next, this is the waveform of the push-pull amplifier. So next, efficiency of class B push-pull amplifier. For that purpose, we are calculating the DC current. From that, we are calculating the DC power. And then to find the AC power, we require the AC RMS collector current as well as RMS output voltage. So from these two values, we can calculate the AC power. So once we know the AC power and DC power, if you substitute in the efficiency equation, we will get the overall efficiency of the class B push-pull amplifier, that is 78.5%. So each and every point, the construction, operation and the efficiency calculation, we have to explain in detail for the given question. And next, draw a circuit for class C amplifier and discuss its working. And class C has the maximum efficiency compared to the other power amplifier, but its use is restricted. Give reasons. So this is the class C power amplifier. We need to explain the operation of this one. The construction and operation of class C amplifier we need to explain in detail. And after that, we need to give the reasons how class C is not used here. It is providing high distortion here, huge amounts of distortion. That's why this class C amplifier we are not utilizing for the audio applications. So the most common application of the class C amplifier is the RF circuits like RF oscillators and RF amplifiers we can utilize here. Where there are additional tuning circuits for the retrieving the original input signal from the output of the class C amplifier. And so the distortion caused by this amplifier has a little effect on the final output here. So input output waveforms are also we need to discuss for this given question. And next, the last question in the critical thinking questions, that is a power amplifier supplies 3 watts to a load of 6K. That is PDC value is given it as 3 watts and the load resistance value is 6 kilo ohms. The zero signal DC collector current is IC is 55 milliamps at no signal. And current with the signal is IC equal to 60 milliamps with the signal. So here we need to find the second harmonic distortion, how much it is. So this problem we already discussed in the problems on power amplifier session. See the formulas from there and try to solve this. And the second part is related to the Lang answer questions. So in the Lang answer questions, the first question is illustrate the different types of distortions that occur in amplifier circuits. Here the 3 types of distortions will occur in the amplifier circuits, that is the amplitude distortion, frequency distortion and phase distortion. So generally this distortion, how it is coming and why it is coming in the amplifier circuits due to the non-linear characteristics of the devices which are using to design that, and the different component levels in the circuit are providing the distortion in the circuit. So if we get the distortion in the amplifier circuit along with the required waveform, there is a noise signal will be present, or else some portion of the signal will be uh, clipped off, or some extra portion may be get in the form of noise. So this indicates the distortion here. So while coming to the amplitude distortion, if we get the amplitude distortion in the amplifier, some level of the signal will be clipped up, that may be in the positive level or in the negative level, some portion of the signal will be clipped off here, or else in some cases the amplitude of the signal will be reduces, that may be in the positive side or in the negative side. So this particular amplitude distortion is a result of non-linear nature of the transistor dynamic characteristics. Because of that reason we are getting the amplitude distortion in the amplifier. And next one is frequency distortion. So this frequency distortion is occurred due to two different level frequency signals are amplified at a time. Okay, input signal are amplified differently. So the factors which contribute to this type of distortion are the device capacitances and the reactive components associated with the circuits. Because of this reason we are getting the frequency distortion in the amplifiers. And next, phase shift distortion. So this phase shift distortion is due to the unequal phase shifts of the signals of different frequencies. So this is caused by the dependence of the phase angle of complex gain of the amplifier on the frequency of the signal. So these phase shifts are due to the reactive effects as well as active devices in the circuits. So generally this phase shift distortion will occur in the TV pictures. So to avoid this, amplifier phase shift should be proportional to the frequency of the signal. So for any amplifier, we may get either amplitude distortion, frequency distortion, or phase distortion, but we have to maintain these values as minimum. Why? Because we cannot eliminate totally. And the second question in the part B is demonstrate the construction and operation of two-stage amplifier with the Darlington connection. Give the advantages of this circuit. What are the drawbacks of Darlington amplifier? So here Darlington amplifier is nothing but the two transistors are connected in cascade in order to improve the amplifier parameters, that will be the gain, voltage gain, current gain, input output impedances. So in this Darlington amplifier, the current gain of the amplifier will be increases more here. So we have to explain the construction of this Darlington pair. Okay, this is the internal circuit of the Darlington pair. And next we have to explain the biasing analysis of this Darlington amplifier. So the overall current amplification is the multiplication of the first stage amplification as well as second stage amplification. So that's why from the Darlington pair we will get the high current gain here. And so here we are proving that particular how the current gain is improving here. Beta equal to beta 1 and beta 2. We have to explain each and every step clearly here. And while coming to the next question, compare the different types of coupling methods used in multi-stage amplifiers. So here we are going to utilize three different coupling schemes. Those are RC coupled, transformer coupling and direct coupling. So in the case of comparison, we are taking the frequency response. In the RC coupled, we are getting excellent frequency response. In the transformer coupled, it is very poor. And in the direct coupled, we are getting the best frequency response. And while coming to the cost, it is very less. Why? Because with the resistors and capacitors and transistors only, we can design this. So the cost of this one is high. Why? Because transformer is costly here. And here also it is cost is low. Why? Because we are not utilizing any coupling elements in the case of direct coupling. And next, space and weight is also less for this for more, and it is also less. Impedance matching is not at all good in the case of RC coupled amplifier, but it is excellent in the case of transformer coupled amplifier. Why? Because it will provide the best impedance matching between the source and load. And direct coupled will provide the good range of impedance matching. While coming to the applications, RC coupled amplifiers are utilized for the voltage amplification, transformer coupled amplifiers are utilized for the power amplification, and direct coupled amplifiers are utilized for amplifying the low frequency signals. Next, describe the terms collector dissipation and conversion efficiency of Class A power amplifier. So, in the case of Class A power amplifier, the efficiency is not more than 30% here. 30% here, but it has got improved to 50% by using the transformer coupled Class A power amplifier. Okay, so DC power drawn from the collector battery is given it as this much here, VCC into ICQ. So this power is used in the two parts of the power amplifier, that is power dissipated in the collector load as well as power given to the transistor. Okay, this derivation we need to do to prove the efficiency of collector efficiency of the given amplifier is this much output power to the input power. And overall efficiency, if you want to find the overall efficiency, we have to take the efficiency of the two stages here and we have to multiply that to get the overall efficiency here. So this is the overall efficiency of the given amplifier. And we're coming to the next problem. In a modified Class B power amplifier, demonstrate how distortion can be eliminated. So in the modified Class B power amplifier means that is the Class B push-pull amplifier. So we need to explain about Class B push-pull amplifier circuit, how the transistors are working in that Class B push-pull amplifier and how the efficiency is improving here and how the distortion is eliminating in this case. We need to explain clearly each and every point for the given question. And next, explain about cascade amplifiers. So here cascade amplifier is nothing but we are taking some two or more stages of single stage amplifiers. By using different coupling schemes, we are interconnecting the output of the first stage to the input of the next stage. So if we can add directly or by using the different coupling schemes, we need to explain the concept of cascading by using any coupling scheme here. Why we are going for the cascade amplifier means in order to improve the amplifier parameters, that may be the voltage gain, current gain, input impedance as well as the output impedance here. So each and every point we need to explain clearly as it is the lang answer question. And next, outline the advantages of push-pull Class B power amplifier over Class B power amplifier. See, the Class B push-pull amplifier ability to work in limited power supply conditions here. Why? Because of higher efficiency and absence of even harmonics in the output here and when it is compared to the Class A power amplifier comparison. So that's why Class B push-pull amplifier is more advantageous compared to the normal Class B power amplifier. So we need to explain the construction of both the circuits and the working of both the circuits, and then we need to mention these particular points to explain this given question. And next, show the push-pull Class B power amplifier and explain its operation. Show that the maximum conversion efficiency is 78.5%. So here we need to take the Class B power amplifier and we need to construct the Class B power amplifier. We need to explain the construction of that one. And next, the operation of the Class B power amplifier. And after that, what is the waveforms we are getting in the Class B power amplifier and how they are getting, we need to explain. And next, we need to go for the Class B push-pull amplifier, the construction of that one and the operation of the Class B push-pull amplifier along with the circuit diagram we need to explain. And after explaining the operation, we have to give the output waveforms of the Class B push-pull amplifier circuit. And next, we need to calculate the efficiency of the Class B push-pull amplifier. So how we can calculate the efficiency? By calculating the AC power as well as DC power. So to calculate such AC and DC powers, we require the DC current and voltage levels. So that's why we are taking the DC current and from that we are calculating the input DC power. And after that, to calculate the AC power, we are taking the RMS values of collector current and the RMS value of the output voltage. So from this we can find the AC power. From this we can find the AC power. So after finding the AC power, we need to find the efficiency, that is PAC by PDC into 100. So that one will give the efficiency of the class B push-pull amplifier. So almost it will get 78 to 80%. And next, show the circuit diagram of Darlington pin circuit. Derive its input impedance as well as current gain here. See, this particular question we already discussed in the previous slide. Okay, we need to construct the Darlington pair by utilizing the two different transistors, and we need to explain the operation of that one, and we need to find the input resistance as well as the current gain of Darlington amplifier. Each and every point we need to explain in detail because it is the long answer question. And next, list and explain different types of differential amplifier configurations. So here, while coming to the differential amplifier, it will perform the difference of the applied two input voltages. For the amplifier, it will amplify the differential voltage. So this differential amplifier can be available in 4 configurations, that is dual input balanced output differential amplifier, and dual input unbalanced output differential amplifier, and single input balanced output differential amplifier, and single input unbalanced output differential amplifier. So depending upon how many number of inputs we are utilizing and how the output signal we are measuring, depending upon the 2 parameters, the differential amplifiers are classified as these 4 types. So these are the circuits for that 4 amplifiers. This is dual in balanced output, and this is the dual in unbalanced output. So here the common output we are taking, and we'll provide the 2 input signals. Dual means 2 inputs, and the output across the common point of 2 collectors we are taking. And dual input means again here 2 inputs we are providing. Unbalanced means at any one collector of the transistor we have to measure the output. And similarly, single input means either we need to apply either VS2 or VS1 for the corresponding transistors, and the output across the common collectors of both the transistors. And next, here also single input, either we can apply for the first transistor or second transistor, but the output we have to measure across the collector of any one of the transistors. Next, demonstrate about power amplifiers. So here in this particular question, we need to explain what is power amplifier and why we are moving for this power amplifiers. We need to explain, and we have to give the different types of power amplifiers what are available here. So as it is the short answer, just to give the definition and types of the power amplifiers. So these are the different types of power amplifiers. We are having audio amplifier, RF power amplifier, and DC power amplifier here. So we need to explain about audio power amplifier, radio frequency power amplifiers, as well as DC power amplifiers. Just what is the function they are going to perform, we need to explain. And next, explain RC coupled transistor amplifier with special reference to frequency response, advantages, disadvantages, and application. So here we need to construct the RC coupled amplifier. We need to give the construction of the RC coupled amplifier, and what is the operation of this RC coupled amplifier we need to explain. And after that, we need to give the frequency response of the RC coupled amplifier, how it is behaving in the low frequency and at high frequency and at medium frequency range. So at low frequencies, how it is giving the response, at high frequencies, how it is giving the response, and at mid frequencies, how it is giving the response, we need to explain clearly. And next, we need to mention the advantages of the RC coupled amplifier and also the disadvantages and applications of the RC coupled amplifier. Though it is the long answer question, we need to explain each and every thing in detail, that is construction, operation, frequency response, advantages, disadvantages, and applications of the RC coupled amplifier. We need to explain in this given question. And next, with a neat diagram, explain the working of transformer coupled transistor amplifier. So as like in the case of RC coupled amplifier, here we need to explain about the transformer coupled amplifier. In this, first of all, we have to give the construction of the transformer coupled amplifier and the operation of the transformer coupled amplifier, as well as the frequency response of the transformer coupled amplifier and how it is giving the response at each and every frequencies, that is at low frequency, at high frequency and at medium frequency, how it is providing the response we have to explain. And while coming to the next question, explain the terms of amplifier, that is frequency response, decibel gain and bandwidth here. So generally the frequency response of the amplifier or filter show that how the gain of the output responds to different frequency signals here. So amplifiers and filters are widely used in electronic circuits that have the properties of amplification and filtration here. Generally this will be used in audio here, and the voltage gain is defined as the ratio of output voltage to the input voltage in dB here. So almost this value is 1 here. And what about bandwidth? So bandwidth will indicate difference between the frequency limits of the amplifier, that is nothing but the difference between the upper cutoff frequency to the lower cutoff frequency. So about these three things we need to explain in detail as it is the long answer question. With a neat diagram, explain the working of two-stage RC coupled amplifier. So in this case, again we need to give the construction of the RC coupled amplifier, okay, and the operation of the RC coupled amplifier, how it is providing the signal whenever we will give the input signal for the amplifier, and what is the frequency response of the RC coupled amplifier at low frequency and high frequency and medium frequency ranges we need to explain. And so these points we need to explain in detail in the case of given question. And next, explain in detail classification of power amplifiers. So generally we are having 4 types of power amplifiers we are going to utilize, that is class A, class B, class C and class AB power amplifiers. So the conduction angle in the class A power amplifier is 360 degrees, and for the class B is 180 degrees, and for the class C is less than 90 degrees. For class AB it is 180 to 360 degrees here. And the position of the Q point T is center of the load line, as it is utilizing the total 360 degrees of the input signal, and it is exactly on the x-axis. It is below the x-axis. It is between the x-axis and the load line. And the overall efficiency provided by the class A amplifier is very less, 25% only. Class B it is improved to 80%, and the class C it will provide the less than 80%. Class AB is between 50 to 70 range it will provide. And the signal distortion we may expect very less in the case of class A amplifier if we biasing properly, and crossover distortion we can expect in the class B power amplifier, and large amount of signal distortion we can expect in the class C, and very less amount of distortion we can expect in the class AB power amplifier. So each and every comparison we need to explain in detail in this given question. And next, demonstrate the construction and operation of differential amplifier. So here, to make the differential amplifier, we have to take 2 identical transistors where those should have 2 similar properties, and the collector resistance of the 2 transistors are also equal, and the emitter resistance of the 2 transistors also must be equal. So we have to take the 2 transistors configurations with 2 similar type of transistors. Then we have to interconnect the 2 transistors by providing the common power supplies VCC as well as VE. So in this way we need to construct the differential amplifier. So the basic function it is providing here it will amplify the differential input whatever we are providing to the amplifier. So this differential voltage is the 2 input signal which we are providing for the Q1 as well as Q2 transistors. So in detail we need to explain the construction and operation of the differential amplifier here, and it will available in 4 configurations. And next, apply hybrid model to common emitter transistor for finding the gain and bandwidth. So this one we already discussed in the previous slides. For the common emitter transistor, we have to apply the hybrid model, and after applying the hybrid pi model, we need to find the gain value, that is voltage gain value, as well as how much amount of bandwidth we are getting. So we have to take the common emitter transistor, then we have to draw the high frequency equivalent circuit of that common emitter transistor, and then we have to do the analysis to find these two parameters. So we have to explain in detail this. And next, outline the advantages, disadvantages, and applications of RC coupled amplifier. So we have to give the advantages of this RC coupled amplifier as well as disadvantages and applications of the RC coupled amplifier. We have to explain in detail. And next, list the various advantages and disadvantages and applications of the transformer coupled amplifier. So for this question, we need to explain the advantages, disadvantages, as well as applications of the transformer coupled amplifier. So while coming to the next part, that is part C, short answer questions. In the part C, we are having total 20 short answer questions here. So here, the first question is, what is mean by bandwidth? So bandwidth is nothing but the range of frequencies within a given band in a particular that is used for the transmitting a signal here. So generally, bandwidth we will calculate from the upper cutoff frequency to lower cutoff frequency here. And next, list the classifications of amplifiers. So here we are having 4 types of power amplifiers. We have to give the function of that 4 power amplifiers and the conduction angles of that 4 power amplifiers. As it is the short answer questions, just we have to give some 3 to 4 points for each and every question. And next, outline the merits and demerits of cascade amplifier over a simple CA amplifier. So if you take the cascade amplifier, generally we may get high gain as well as high input impedance, and the output impedance should be low here. If we cascade the different single stage amplifiers, we will get the multi-stage amplifier or cascade amplifier here. Okay, and the amplifier parameters are improves more in the case of cascade amplifiers compared to the single stage amplifier. And next, to define distortion. So distortion is nothing but we from the amplifier we are getting distorted signal along with the original signal, that may be due to the non-linearities of the components or non-linear dynamic characteristics of the transistor because of any reason, or due to the linear elements, or due to the reactive components of the circuits. Because of all these reasons, we may get distortion in the circuit. So distortion is nothing but there is a variation of the output signal. The shape of the signal may vary here, either phase angle and frequency of the signal may also vary. And illustrate the types of the coupling schemes. Here we are having 3 types of coupling schemes, that is the direct coupling, RC coupling, and the transformer coupling. So just to give what is meant by direct coupling and what is meant by RC coupling and what is meant by transformer coupling for the given question. And next, list the advantages of multi-stage amplifiers. So multi-stage amplifiers are providing the very high gain, very high input impedance and low output impedance here. So these are the major advantages of the multi-stage amplifiers. So that's why we can able to utilize for the high frequency applications this particular multi-stage amplifiers. And next, outline the need for cascading here. So here cascading amplifier or need for cascading is used to increase the amplifier output to meet a specific requirement, or in order to improve the strength of the signal and in order to improve the parameters of the amplifier, we can go for the cascading here. That is nothing but higher current gain and voltage gains we will get, and there is a variation in the input output impedances also we will get because of the cascading of 2 or more stages of the single stage amplifiers. And next, classify power amplifiers. So these power amplifiers are divided into 2 types by linear conduction angle or by using the switch wave shaping. So due to the linear conduction angle, these are divided into 4 types, that is class A, class AB, class B and class C power amplifiers. And in this case we are having class D, class E and class F power amplifiers. And next, list the advantages of class B operation. See here, the class B amplifier has the advantage has no current flows through the transistor when they are in their quiescent state. So that is the basic advantage of the class B power amplifier. Because of that, there is no power waste in the circuit and there is no power dissipation in the circuit whenever we are not applying the signal to the amplifier, unlike in the case of class A power amplifier. In the case of class A power amplifier, power dissipation will be there even though we are not providing the input signal. And next, define power amplifier. So power amplifier is nothing but one type of the electronic amplifier. It will improve the strength or magnitude of the power level or magnitude of the power, whatever the signal we are applying to that power amplifier. So the power of the input signal is increased to a very high level to operate the loudspeakers as well as headphones, RF transmitters, etc. So in order to run the high frequency applications, we require the power amplifier. Why? Because it is providing the high power signal as the output. And next, what do you mean by gain bandwidth product? Here, gain bandwidth product is the product of the gain as well as frequency at which a particular point is measured. So we will indicate in the form of hertz here. Define differential amplifier. So here differential amplifier is one type of the electronic circuit which amplifies the applied differential voltage for the amplifier. It is nothing but for the two inputs of the differential amplifier, we will provide the inputs and it will take the difference of the two inputs and it will amplify that differential voltage. And next, outline the drawbacks in a class A power amplifier. So, while coming to the disadvantages or drawbacks of the class A power amplifier, due to the large power supply and heat sink, these are costly as well as bulky here. And while coming to the efficiency, it is very poor in the case of class A power amplifier. Due to the transformer coupling, the frequency response is not good in the case of class A power amplifier. Demonstrate the circuit diagram of Darlington pair. So this is the Darlington pair by utilizing two transistors. So this is the PNP form, it is the NPN form. We can also represent it as the single form. So we have to explain some few points related to this circuit for this question. And next, define frequency response. Frequency response is nothing but how the particular system is responding for different frequency range of signals here. So some systems may amplify frequencies of certain range and that same system may give attenuation for the other frequency range. So the system output is related to the input for different frequencies is called the frequency response of that particular system. And next, list the applications of a differential amplifier. So generally this differential amplifier we can utilize for the volume control circuits and we can also use it for the amplitude modulation also. Explain the concept of cascading. So again, cascading is nothing but we are interconnecting the two or more stages by providing the output of one stage to the input of the next stage in order to improve the parameters of the amplifier here. Okay, so because of this cascading we can able to improve the total parameters of the circuit, and some cases cascading will lead to the non-perfect coupling that will become the loading effect on one stage to the next stage. So while cascading we need to take precautions or we need to give proper coupling elements between the two stages. And next, identify the transistor configurations used in Darlington pair. So in the Darlington pair, we can utilize either two NPN transistors or two PNP transistors connected together so that the emitter current of the first transistor TR1 becomes the base current of the second transistor. So that's why we can also make it as the single transistor. And next, list the transistor configurations used in Cascade amplifier. So in the Cascade amplifier, we'll utilize one is the common base amplifier and one more is the common emitter amplifier here. So if we interconnect the two stages, we can able to form the Cascade amplifier. We need to give some 2.2 to 3 points related to this Cascade amplifier. And next, define gain bandwidth product. So it is the product of the gain as well as the bandwidth of the particular amplifier here. So that indicates the gain bandwidth product of the particular amplifier. So in this session, we have discussed the questions related to the multi-stage amplifiers as well as power amplifiers. In that, we have discussed three different categories of questions. The first part is about analytical and critical thinking questions. In that, we may expect either theory or most of the problem related questions. And second category of questions is part B. Those are the long answer questions. We need to explain elaborately each and every point as well as circuits in that particular questions. And the third part belongs to the short answer questions. In that, we have to give some 4 to 5 points of explanation for the given questions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.